this example, we will see how naive-Bayes algorithm is used for classification. We have a given table with the information about 22 individuals, and they are tested for the possibility of diabetic symptoms. In order to check whether the person is diabetic or non-diabetic, their blood pressure and the blood sugar, these two parameters are measured. Total 22 such individuals are examined, and out of that it is found out that there are total 16 number of diabetic patients and 6 are non-diabetic. So these are two classes, diabetic patient and non-diabetic patients, denoted by D and N. Out of the diabetic patient of 16 numbers, 7 of them have blood sugar, high blood sugar, and 9 of them have high blood pressure. Out of the 6 non-diabetic patients, 3 of them have high blood sugar and 3 of them have high blood pressure. But here the point is, although they have high blood sugar and high blood pressure, 6 individuals are not detected as diabetic. This is the observation made from 22 persons. Now a new person is examined and he has found a high blood sugar and high blood pressure. Now still, from the previous observation, it is found out that although the person have high blood sugar and high blood pressure, he may not be a diabetic patient. That's why we have to find a possibility of the new person, whether he is diabetic or he is non-diabetic. That is called the new data point need to be classified into any one of the classes that is derived from other data points. In this case, in order to classify the new data point, we will be using the naive Bayes algorithm. In this video, we'll see how this problem is solved using the said classification method. To solve this problem, or to find whether the new data point with the to check whether the newly arrived data point belongs to the diabetic class or non-diabetic class, what we need to do, first we have to check whether the probability of X being a diabetic patient, P, X, D is used for diabetic patient class. We have to find the probability of X being diabetic. What is the probability of X being diabetic? Second, we have to find the probability of X being non-diabetic. And whichever is the greater value will be considered the class of that particular newly coming data point X. Since here we have only two classes, if we find the first one, that is the probability of X being diabetic, then to find the X being non-diabetic, we can write down as 1 minus P X being diabetic. So this will give you the probability of X being non-diabetic. So first of all, we will see how to find the probability of X being diabetic. Probability of X being diabetic can also be stated as the probability of X for a given probability of diabetic patients. It means that we know the probability of being a diabetic patient out of 22 total patients, which is actually 16 by 22. So here 22 is the total sample size. In the sample size, out of 22, 16% are detected diabetic. And similarly, based on the information that we have, we can find out the probability of the X being diabetic or X being non-diabetic. With the given tabulated observations of 22 individuals and with a new incoming data point X with high blood sugar and high blood pressure, now we have to determine what is the probability of X being diabetic. Or in the other words, we need to find the probability of X for a given diabetic information. Or the given diabetic probabilities, we can get it from the observed information which is given in the table. Now let us see how to compute this probability of P, probability of X being diabetic. Let us assume diabetic is indicated using D. For that, we have to find out the probability of the person having sugar being diabetic multiplied by probability of a person having high blood pressure being diabetic. Here S is representing the high blood sugar and P represents high blood pressure. For simplicity, we are assuming P and S, and these values P and S, these are basically the features that determines the class of a particular individual. These features, also known as independent variables. Now, based on the independent variables, we will find the probability of X being diabetic. That is our main interest of computation. To calculate the probability of S being diabetic, what we need to do? Here, when we compute the probability of S being diabetic, indicates that for a given information of diabetic patients given D, what is the probability of a person being diabetic provided his sugar value or sugar level is indicated. That is our main interest of calculation. Now here the problem is, if a person X, he has high blood sugar, does not mean we cannot tell whether he will be diabetic or not. But one thing from the given data we can tell, we can find out the probability of a person who is diagnosed as a diabetic, what is the probability of having sugar? That what I want to say, from the given data, it is difficult to find what is the probability of a person being diabetic if we know the sugar level. This is difficult to find. However, we can find the probability of having sugar in diabetic patients. In diabetic patients. Because in the given data set, the information we have in our hand is the diabetic patients, and also we have the patients with sugar level. That is why to find the probability of a person with sugar being diabetic may be calculated using the Bayes theorem. Bayes theorem. Here is the point where we apply Bayes algorithm. So in this case, the probability of S being diabetic may be calculated as probability of diabetic patients having sugar multiplied by probability of patients having sugar and probability of the diabetic patients. All these informations we can have it from the given database or data set. First term P D for given S is known as likelihood. This is known as likelihood. Probability of S, it is known as prior probability. And probability of D is called evidence. And probability of S for a given D, it is known as posterior. Now we will compute the probability of a person having sugar level high as diabetic patient using Bayes algorithm, basically the Bayes theorem. Here we need to calculate the first term P, probability of the diabetic patients having sugar. This we can calculate from the given table. Here total number of patients having sugar is 10, and out of that 7 are from the diabetic class. That's why this value will be 7 by 10. Second one, the probability of having sugar. This value may be calculated total person having sugar is 10 and total observed individuals are 22. That's why this value is 10 divided by 22. And finally, the value of probability of D means probability of diabetic patients. Total number of diabetic patients are 16 and total individuals examined are 22. That's why this value gives the 16 by 22. Now putting all these values together, we will have P, probability of S for given D. We have P D for given S is 7 by 10 multiplied by 10 by 22, which is probability of the person having sugar, divided by 16 by 22. If we cross out this 10 and 10, this 22 and 22, it gives the value 7 by 16, which is approximately equals to 0.4375. Since the probability of X being diabetic our main interest is to find the probability of X being diabetic or non-diabetic. So probability of X being diabetic is equals to probability of S being diabetic multiplied by probability of P being diabetic. That means probability of the person having sugar classified as diabetic and probability of a person having high blood pressure is recognized as a diabetic patient. So we now have to calculate the term P, probability of a person having high pressure as a diabetic patient. Let's calculate again the same thing. Probability of a person having blood pressure diagnosed as diabetic is given as, using Bayes theorem, probability of a person with diabetic having high blood pressure multiplied by probability of person having high blood pressure divided by probability of diabetic patients. So it gives the total value D by D for given P, which is nothing but 9 by 12 multiplied by 12 by 22 divided by 16 by 22. And if we cross out this 12 and 22, it gives you a value of 9 by 16, which is equals to 0.5625. Hence, probability of X being diabetic is equals to probability of S being diabetic multiplied by probability of P being diabetic, which gives a value of 0.4375 multiplied by 0.5625, which is equals to 0.2460. 2460. This is the probability of being diabetic. So the probability of X being diabetic is equals to 0.246. Now we need to calculate the probability of X being non-diabetic. For that, either we can calculate the probability of S being non-diabetic multiplied by probability of P being non-diabetic. And this probability of S being non-diabetic and probability of P being non-diabetic, that can be computed using the Bayes classification method. Since we have only two classes, that is why probability of X being non-diabetic may be computed as 1 minus probability of X being diabetic. I think it's if we compute this way also, there is no harm at all. So that's why it is actually 1 minus 0.246, which gives you a value of 0.754, almost 754, and which is greater than the probability of X being diabetic. Hence, this newly coming point X with the symptoms of the blood sugar and high blood pressure belongs to the class non-diabetic. non-diabetic.